Alright guys, so here is the FRQ posted on Thursday. So we're looking at a graph. The graph is a function g. The function g is defined on the closed interval from -4 to 8. The graph of g consists of two linear pieces, right here and right here, and a semicircle right here, as shown in the figure above. Let f be the function defined by this. So I'm going to box that. What I notice is that f has a linear piece, and then it is also determined by the area under the g curve, or between the g curve and the x-axis. So they want me to find f of 7 and also f prime of 7. I think the first thing I'm going to think about here is what would the derivative of this function be? The derivative of the linear term 3x would just be 3. And then when I think about the derivative of a definite integral, I remember in chapter 6 when we studied the fundamental theorem of calculus that the derivative of an integral just undoes that function. They're like inverse operations, and I just get the g function back. And then it's okay to plug in g of x. G of x or g of t, it doesn't matter. So the derivative of f is going to be 3 plus the value of the g function. I'm going to keep that because we're going to need it later also. All right, so let's find f of 7. That means I'm going to multiply 3 times 7. And then I'm also going to calculate the area under the curve from 0 to 7 of g of t dt. So I'm thinking about area. Starting here at 0. From 0 to 6, it's determined by the semicircle. So I'm going to make sure that's pi over 2r squared. Pi r squared divided by 2 because it's a half of a circle. And I'm also going to make sure when I add it into the function that I make it negative because it's under the x-axis. But they wanted me to go all the way to 7, so I can't forget to add on the area here. So here is a linear function. The area under that curve is this tall rectangle, so I also have to add that area on. All right, so this is 21 plus, I've got negative, let's see, the radius here is 1, 2, 3 units long, 9, because the radius squared would be 9 times pi over 2, plus the area of this rectangle, which is a 3 by 1, so it's 3. So just to make sure we're clear, that's the matching area here and then here. So we could leave it like this, but it's good to be more concise. So 21 plus 3 is 24, okay? Plus 9, plus a negative, 9 pi over 2, so just subtract 9 pi over 2. There we go. There's f of 7, so that was 1 point that we've earned. And then f prime of 7, now I've got my f prime function, so it's just going to be 3 plus g of 7. So I'm going to need to use the graph. The value of the g graph at x equals 7 is right there. So g of 7 has a value of 3. So f prime of 7 is 3 plus 3 after we use the graph to find that value. So f prime of 7 is 6. There's the other point. So there we have part A. Check that out.